So welcome everyone online and here in Zurich. Welcome Alexandre Akchoti. Do I pronounce it good?
Yeah, it's Akchoti. Thank you.
Akchoti. For being there. As you can see on the slide, you will talk about your company here in Switzerland, distributing products based on Lime-Hemp and hemp, but you will explain it much better. I have to thank you for all what you do for this CIS. This week you helped us, you support us a lot, especially for the Thursday, the hands-on we will do. We will use a lot of your materials, so thank you for offering us all this. It's going to be fun. And I think you will come on Thursday morning.
Yes, I will be there. Yes.
You have the floor.
Thank you very much, Arno. It's a great pleasure being here. It's a great pleasure to have this opportunity to share this conversation with you. So the title of the presentation is Lime-Hemp. Why I think why is an important part of everyday life. The question I ask myself on a regular basis. Of course, not every 10 minutes, but from time to time, I remind myself to ask myself why I do this, why I think this, why I use this or behave in a certain way. And I think it is also important in this context when we talk about Lime-Hemp in general. As I believe it is really important to understand the background. Also, now we talk of building material to make sure that it is appropriate in the context you plan to use it for, and to make sure that it is exactly adapted, I would say, to your needs and whatever you want to achieve with that specific material. By the way, whether it is Lime-Hemp or not, of course, doesn't make any difference. So a very brief explanation of Structura C, the background. The name comes from the Latin. Structura means, or one of the translations of the word structura from the Latin to English is construction method, and the C stands for calx cannabis, which is Lime-Hemp. Okay, so that's the background. I founded the company almost 3 years ago now, as I decided to make a contribution in the building sector in this case. Our I would say motto, if I can call it this way, this is probably more of a French word, but the slogan is the English word, the house that breeds. So this is absolutely central in our approach. But going a little further, of course, we want to provide 100% sustainable materials. Of course, we focus, everybody understood it, I think, thus far on Lime-Hemp materials. And we use, I mean, the materials we use are mixed with aerial lamp. We'll get into this a little later. There are some specific reasons for that as well. And we use it for drywall construction, indoors, outdoors, and the quality is absolutely central for us. And when I talk quality, it's not only about materials, it's also about services. We want to make sure that we accompany our customers in the process from the design, talking of the project phase, starting project phase, to the execution on the construction side. So we strongly recommend, particularly our customers that don't yet have much experience working with these materials, to make really good use of this service we provide, as this helps a lot to achieve, I would say, good results at the end of the day. So sometimes when I meet customers, what they tell me is, wow, great, fantastic, this is a new technology. So we love it, it looks great and so on. And then I tell them, well, yes, humanity used it already 3,000 years ago. So the Ellora caves, for example, you might have heard of that, and otherwise, please don't hesitate to use Google. Although it's not fully AI compatible yet, or as good as ChatGPT. But jokes apart, I mean, they used in the Ellora caves, they used aerial lime, by the way, or hydrated lime, to get a little bit more into the details, to cover the paintings they did, which helped conserve those paintings and also helped to keep a very agreeable environment in the caves. So this is talking of lime, but talking of Lime-Hemp, more particularly, the Romans used it here and there. The Colosseum was partly built with Lime-Hemp around 2,000 years ago, as we probably all know here. And accordingly, these materials are not that new. What is new, of course, is the whole industrial approach we have today, and the fact that we are able to make it available to a broader public, I would say. Market vision and outlook. Clearly, we want. I mean, everybody, I think, in this session and in the whole audience here, I believe it is our common goal. We want to contribute to build healthy living spaces with a minimal ecological footprint. I underline the word minimal because I think it's very important to stay realistic all over the place. Because sometimes I hear people that tell me, oh, you know what, so we just want to use 100% fully ecological materials and so on. And I tell them, well, yes, but you need to make sure that everything works out at the end of the day. So it is, to stay realistic, pretty much impossible to build fully ecological materials in our society here in the West. Okay, so of course, if you are in the middle of a desert or whatever, we can you know try. I mean, use only whatever is there, the earth and so on and so forth. But in the middle of Zurich, if you tell me you want to use only 100% ecological materials, I will tell you, well, probably I wish you good luck. I mean, there are some norms we have to keep. There are some building from a statical point of view requirements that we need to fulfill, and so on and so forth. That's why I emphasize on the word minimum. But let's continue. I mean, we expect strong growth. We experience strong growth altogether. Of course, there is a lot of interest because of the political pressure. In the US, there is, of course, a little shift with the Trump administration, but at the end of the day, the awareness is there as well. And this is the second bullet you see here. And the third one is the willingness to contribute to a better future, which is, as I mentioned it earlier, also my main goal. So talking of the opportunities here, we have, I split it into two, the conventional construction sector on the one hand and the public sector on the other hand. Talking of the conventional sector, we have the private owners, which are basically I would say, the ones who start because it's smaller projects, it's less risk involved for private individuals. Of course, there is always a risk. Of course, there is, I mean, a risk in the sense that it's new, and if you don't have experience, you generally are a little, I would say, reluctant or at least careful about the projects, and that takes us quickly to the second point, which are institutional investors. Of course, institutional investors invest billions into real estate projects, into property development, and accordingly, they are also a little more careful about what we're talking about and why. And of course, here again, we need to be very realistic. They expect a return on investment. Clearly, there is a return on investment, and it can be even much stronger than what they get today with the conventional materials. But this requires a little mindset change, particularly talking of the costs and the calculation and the way. That's what I mean, really. The costs are calculated. We'll get into it a bit later in the conversation. And of course, the bigger construction companies, because of course, if you have the private owners and institutional investors that want to start to build in this way, well, the building companies need to get to understand what we're talking about. In this sense, I got already several contacts by fairly big construction companies that want to understand these type of materials and want to understand how they can then implement it on the floor, on the construction site. And accordingly, we already have also, and we will see some of those later, projects where we already get involved with bigger construction companies as well. Talking of the public project, politics, again, the pressure is there. As a matter of fact, I was on a business trip last week with the government of Baden-Württemberg in Germany. It was a trip, although the trip was in France, but it was a delegation, and it was highly interesting because clearly, to me, that is a confirmation of how involved the governments, at least clearly still today in Europe, are into this, and the willingness to make their contribution as well in the building sector. And of course, this has an impact then on districts, municipalities, regions, as I mentioned it earlier, and that means that the pressure is higher and higher to get projects that include a big share of ecological building materials altogether. And last but not least, I mentioned it already earlier, and I introduced it. It's the way we make price calculations and the way we approach the whole pricing model or costing model, if you prefer, of the project. And I mean, I would say keywords here are short versus long-term thinking. Okay, and we'll get a little more into details later. Talking of the mixture, Lime-Hemp is not same as Lime-Hemp all over the place. I think it is really important to understand this because sometimes people come to me and they say, "Oh, it's Lime-Hemp." I say, "Yes, it is Lime-Hemp." But clearly, the mixture you use to make Lime-Hemp, it has an impact on the mechanical, but also the hygrometrical properties of the material in this case. So I think it is important to be aware of this, whatever it means, and it means different things in different cases, as you understood. In this case, we will talk about this mixture. And by the way, the lime you see here on the right side, I mentioned it briefly earlier, is aerial lime, and to be more precise, it's dolomitic lime. Okay, so dolomitic lime has, and here we get a little technical, but I will stop quickly there, has molecules of magnesium in it. So there is a clear reason why here we use dolomitic lime, because this helps to increase the resistance of the material. And at the same time, the hydraulic lime, which is the aerial lime piece, helps to keep elasticity, to keep it simple in the material. Because of this mixture, and not only because of that, but a lot of it is due to this mixture. There we have a certification, CO2 negative, EPD certification. That means, I mean, concretely, that since we started, we have removed 1,591 tons by the end of March 2025, so a week ago, to be pretty much precise, out of the atmosphere. By the way, if you're interested, 1 hectare of forest captures 5 tons of CO2 per year. Okay, that means that 1,591 tons of CO2 are the equivalent of 318 hectares of forest in 1 year. Just to give you a sense of the dimensions. The advantages, I think many of these are absolutely obvious to the audience here, but the one which is a little trickier, particularly for people who are not very experienced yet with Lime-Hemp, is this one, fireproof. And we will get a little into details later, but other than that, I think there is also another one which is a little tricky, and I have many conversations around this one. It's the fact that it is highly efficient, talking of energy savings. There have been several buildings built that do not need any cooling or heating anymore. That means 0.00 kilowatt hours heating or cooling energy anymore. Products and applications. Here you have some examples, and on the lower line you can see where in the building Lime-Hemp can be applied. The bricks can be combined with the load-bearing structure in wood, steel, or reinforced concrete, of course. Bulk Lime-Hemp can be used to insulate roofs, floors, walls. We'll see examples later. And on the upper right side, what you see is plasters made out of Lime-Hemp that can be used in different circumstances. Some of the advantages, we already covered this slightly, but here there are a couple of points that come on top. I think let's start with hemp as such. It's really a highly ecological crop. You can read a lot on the internet if you're interested, and I'm talking of industrial hemp, to be clear, which is not exactly the same as the TCH or higher degree of TCH holding hemp plant, which is a different plant, by the way. In 2 to 4 months, the crops get up to 3 meter high, sometimes more. During the high season and with very good atmospherical circumstances, the crop grows around 10 centimeters per day. So it's very fast. The cycle is very fast, as you can notice. Easy implementation. We'll get into the details of that later. Highly efficient thermal installation. We covered it already. Energy savings, I mentioned it already. fireproof, we went over it. Naturally protects from insects and rodents. What does it mean? That it means that whenever you use lime, for example, ants, they just hate this type of environment that is generated by the lime because it has a it generates highly neutral environment from a chemical point of view that they don't stand. So ants are not going to get into this material because of the aerial lime in this case. And rodents, talking of mice or rats, they hate, for example, they hate the smell of the hemp, so they don't get close. So in a very natural way, you get rid of many insects and rodents. CO2 negative, we discussed it already, and generates a healthy and comfortable living space in the buildings built out of Lime-Hemp. We generally have between 50 and 55% of humidity. These materials are fully open. That means that you always have an exchange of air, of course, in a slow way because of the thermal mass of the material. We can get into this a little later, but accordingly, you have a very healthy and agreeable environment in the buildings. We have highly competitive costs. I'll give an example here, a concrete example. I got a call at some point from an architect. He told me, oh, we want to use your materials. It's great, but it's really very expensive. And then I told them, listen, let's get together. You show me your project and I will make some recommendations. And if you accept those recommendations based on that, I will make you an offer. We had a meeting, 5 architects at the table and so on and so forth, went over the project. I made my recommendations based on that. They agreed, and I made an offer based on that. And they called me a week after they received the offer and told me, hey, Alex, it's incredible. We are cheaper than with the conventional materials. So is there a mistake? I said, no, there's no mistake. That's exactly why I wanted us to meet. Okay, so this is what I mean by highly competitive. It's not always the case. I want also to be clear about that. It's not always cheaper. It all depends, how you want to implement it and where you want to implement it in your building. But at the end of the day, even if we are more expensive, the cost is by 5 up to 10% maximum over the other materials or more common materials you would use. And this being said, you don't integrate the energy savings we discussed earlier. You don't integrate the fact that you generate a much healthier and comfortable environment, and the fact that these materials are extremely long-lasting. It's the last one. As I mentioned it earlier, the Romans partly used these materials to build. So the Colosseum is still there. You can go and have a look if you don't believe me. Okay, so what does it mean? Long story short, it means that if your load-bearing structure is there, the material will be there. As long as your load-bearing structure is there, the material will stay. Okay, but of course, if you take it out, then you have to take out everything, and then we can have a conversation around recycling and so on and so forth. But I would say, hopefully, that's not the goal when you start looking into a project. And of course, it is biodegradable. Good. Here, some examples of applications. This is the spraying of Lime-Hemp. As you can see here, there is a skeleton frame. The reason why there is a skeleton frame built, by the way, out of wood, as you see it, it's to prevent lime-hemp mixture, the lime-hemp mixture from falling down. Okay. This is a finished sprayed wall. Just to be clear, sprayed lime-hemp walls require external and internal, or outdoor and indoor plastering. Sometimes people don't like to hear that because they, oh, it's beautiful, I want to keep it this way. And then I say, well, yes, it is beautiful, but I strongly recommend to plaster it. There are several reasons for that. These are examples of applications of the bulk lime-hemp mixture. On the left side, as you see, it's a roof. On the right side, it's a floor. Here we have the combination of the bulk lime-hemp together with the bricks, lime-hemp bricks. And this is particularly interesting, or also interesting, let's put it this way, when you have older walls that don't have a regular surface anymore, and you want to work with lime-hemp, then you can use the bulk lime-hemp to fill the gaps or the spaces you leave before the lime-hemp brick wall. This is an example of a construction site. This was last year, by the way, in the Alps, to be more precise, in southern Engadine. The village in which this was built has the reputation of being the coldest village in the Alps, up to -30 degrees Celsius, just to be clear, peak temperature. It's the 5th building we built in that village. So the first one was around 11 years ago. And then people were happy, were talking about it, and they enjoyed it. And so altogether, at some point, the owner of the hotel came and said, I want to use lime-hemp to build my hotel. And this hotel opened November last year. This is the end product of it's one room. To give you an example of course, it is decorated here. The wall in the middle is also has a lime-hemp plaster, by the way. This is an example of 2 multi-story residential and commercial near zero energy building. 61 apartments or flats, you prefer. This building has won a prize, sustainability prize. And by the way, energy class of the building is A+, just to be clear. This is a project in Basel, in the city of Basel in Switzerland. It is a historical site, so it's a protected site. And the owner of the building, this is one of the buildings of the Christoph Marian Foundation in Basel, and they decided to use these materials. The architect pushed a lot, but this is the second site where they use these materials. What is a little probably even more interesting is the fact that this is the same building, but it's a different part of the building. This is a fireproof wall, just to be clear. And I'll get a little more into the details because I think it is important in this conversation. This is a so-called vertical emergency exit way, the way we define it in Switzerland. Okay, so that means that you have the highest fire resistance requirements according to Swiss norms. Okay, EI 60 RF1, and it's fulfilled. Just to be clear about what I meant earlier, talking of fireproof. And the canton of Basel, based on my experience in Switzerland, is one of the strictest. We're talking of fireproof regulations. Here, I want to show you a couple of visualizations of a building project. The construction site is planned to start in September of this year. This is the recycling of an old industrial site. So it's, in my opinion, a very interesting project. Talking also, the combination of recycling and using ecological materials all together. The name of the project is a house for two brothers. I translated from the German. It's in the canton of Solothurn in Switzerland. And the reason why I want to show you this is I think it is one example of how you can combine fairly modern architecture with Lime-Hemp. So here you see another visualization, and here the third one. If you don't know there is hemp lime in there, you will probably never find out. This is an example of a Lime-Hemp plastered facade of an older building. This is a tiny house built out of Lime-Hemp with also Lime-Hemp plasters. Okay, why I want to show you this. This is a fairly interesting application of Lime-Hemp combined with, as you see it, so on the left side it's before, on the right side, as you may imagine, is after, okay? So what you see on the left side is a wooden roof, and on the right side, the ceiling made out of Lime-Hemp logs. So this is a fairly special construction methodology. I agree, but it is, in my opinion, in this type of circumstances, quite an interesting application of the Lime-Hemp bricks. Of course, then it gets plastered, covered, whatever, and you won't see it anymore when it is finished, and unless you know you have Lime-Hemp bricks in there. Next slide, flat rooftop covered with Lime-Hemp rings, reinforced on purpose. If you look at the right picture, you understand very quickly why. This is a combination, and this is going back to what I said earlier, to stay realistic about, the minimal ecological footprint. This is one example of why I said that, because this is a combination with concrete, of course. So some people look me with such eyes when I show this, but here, this is the only way in this very specific setup to get rid or replace, let me be more polite about the polymer-based materials. Okay, so going back to minimal ecological footprint and the fact of staying realistic. That's what I meant. One example. This is a project in a fairly exclusive area of Tokyo, in Japan. So the construction work started. Why Japanese like Lime-Hemp, because I mentioned it briefly earlier. The fact that we use, or the fact that there is, let's put it this way, dolomitic lime in the mixture, as I mentioned it earlier, make the material rigid. But at the same time, we have a component of the aerial lime, which is hydrated lime, that keeps, and here we talk about the mechanical properties of the material, the elasticity of the material. That means that this material is very adapted in earthquake regions. And this is one of the reasons why the Japanese, and there are already several projects ongoing in Japan. This is by far not the first one. Love these materials. The other reason why they love these materials, some of you might know a little bit of the Japanese philosophy and approach to life. They very much appreciate high quality. So they love the quality of these materials. Here, I want to show you a video. It is a property development project. It's an ongoing construction work. So the site is still open, construction site, 1,200 cubic meters of Lime-Hemp bricks. And as you will see, it's used for partition walls, infill of reinforced concrete load bearing reinforced load-bearing concrete structure. It was done, I mean, the video was done with a mobile phone. Don't be surprised, it's not a highly professional video, but I think you will get a sense of what's going on. And particularly the applications, because I think it's a good mixture of applications you can see here in this building.
Have to be plastered or not necessarily?
Indoors, not necessarily with the bricks. Yeah, with the bricks, you can leave them like that if you want. But this is a property development project. It's quite a big project. So the owners are going to plaster it.
And for fire resistance, do you need to plaster it, or it's also fire resistant without plaster?
Well, it is in this case. Sorry, it is EI 180 certified, by the way. So if you need more, then yeah, you can cover it with plaster. By the way, that was the case in Basel, because that wouldn't have been enough. They wanted both EI 60 plus RF1. This is another example, University of Pisa in Italy, the Faculty of Veterinary Medicine, 700 cubic meters of bricks, 31 tons of CO2 found in the envelope. Another example of a project in Rome, Italy, 950 cubic meters of bricks, 42 tons of CO2 found in the envelope. An example of a project in the UK. Another example in the UK, a renovation project. And this is the last slide. Acceleration, what do I mean by acceleration? I think that we really need to keep a higher political pressure. We need to make sure that the legal framework is adapted, because today the norms that are in place in Western Europe clearly are not really adapted to natural materials, ecological or biosourced materials in general. By the way, it has nothing to do with Lime-Hemp in particular. Of course, Lime-Hemp is part of that, and incentives. Clearly, I mean, the incentives today people get for using polymer-based materials are much easier to get than the incentives you get to use this type of materials. And I hope strongly that this will change. And of course, a stronger push in education. Here we're at the right place, I guess, but it needs to be much broader than this. I mean, it really needs to cover all of the functions in the construction area, I believe. And I think we really need to push for much more of education at all levels in the construction and area. And of course, regular communication media, in particular about the long-term benefits of these materials, as in my opinion, again, this is what is central in the whole conversation here. And of course, we can talk of recycling as well. Of course, we can talk about reuse and cradle to cradle, as we all know. But I really think we need to change the approach to construction in the sense of think long term. I remind you of the Colosseum in Rome.